In this lecture, we will use this example: f of x equals e to the x plus 3 and then plus 9. Use this exponential function to find out the inverse function of this exponential function, to find the inverse, and find the domain and the range of this inverse function. We know there are two general steps to find out the inverse function. The first step is always solve for x, because if we replace f of x with y, y is actually solved, expressed by x. So solve for x means use y to express x, or we say to isolate x. Okay. Now to isolate x, you got to move 9 to the left hand side. So positive, negative cancel each other. And then the right hand side is e to the x plus 3. And then the left hand side is y minus 9. Okay? Yeah. We probably have seen the common techniques many times. It's up to this far because the variable is an exponent. We like to move x plus 3 down. How to move it? Both sides choose log, natural log. Okay? If you choose natural log, and then x plus 3 goes down, exponent goes down. So x plus 3 goes down, and then natural log e. Between x plus 3 and natural log e is multiplication. That's left hand side. Right hand side is natural log y minus 9. Remember, natural log e is 1. This is again also a very common value. If you don't remember, again, you can turn on your calculator, and then natural log e is on the left top part. You do second e. E to the what? To the 1 is still e. So natural log e is 1. So this number is basically 1, huh? If it's 1, you don't have to write. Let me, write it like x plus 3, and then natural log 1 minus 9. Okay. Isolate x again. So minus 3 on both sides. You cancel positive, negative 3. So x then is natural log 9 minus y minus 9, then minus 3. So that's step 1. You are done. Step 2, exchange x and y. So you see y, you write, you see x, you write y, and then you see y, you write x. Okay. Or f inverse of x is natural log x minus 9 minus 3. So you see, you are done with that. Okay. Now, what is the domain? Remember, anything behind the log has to be positive. Okay. So, x, let me write it here. From x minus 9 greater than 0, both sides plus 9, you cancel positive negative 9, so x has to be greater than 9. And then the domain is x greater than 9. Or you may write in integral form from 9 to positive infinity. Okay. Remember, here is round bracket. 9 is not included. Alright. Now, what is the range? The range is what? You know, the log can have a value. You see, log can have a value if you put 2 there, you are positive. If you put what? Log 0.5 there, it has negative. So basically, the range of this inverse is what? All the real numbers. Okay. You know, another explanation is what? You have a let me put natural log x here. You see, this was the picture for natural log. Natural log. Okay, again, y-axis is the asymptote. This curve shouldn't hit this y-axis. Okay, this is because of the pixels problem. Okay, so y is the asymptote. The curve can never reach y-axis, but can be as close as you want it. This is for natural log x. And this function is actually what? 9 units to the right, and 3 units down from what? From y equals natural log x. Okay. So you may draw that. You see, let me put natural log x minus 9 and then minus 3. Grab it. Oh, it's actually too far away. Oh, here it goes this one. So you may set your window like what? X goes from, instead of negative 10 to 10, you may say let's do 1 to 19. Maybe negative 1. So negative 1 to 19. There's window for x. Okay, so it's actually shifted. Previously was here, now 9 units to the right. Okay. You may say, hey, it didn't go, it goes down. But it actually goes down. Okay. As deep as you want it, and there can be as high as you want it. Okay. So please review this one. I'll see you next time.